Hello everyone. In this video, I discussed the product rule for derivatives. So, product rule we use when we have product of two differentiable functions of x. Let's say u and v are two differentiable functions of x. Then the derivative of the product u times v is given by. So you can find the formula using the definition. So I'm not going to do the derivation of the formula, but I'm going to just tell you the rule. So the derivative of the product is first function times derivative of the second function plus second function times the derivative of the first function. Or if you want to write in the other notation, so you can write in dash. So uv dash is equal to u times v dash plus v times u dash. So people have many creative ways to remember this. So some people like to remember this in the song form. So if you look here, so we have 1 d2. So d stands for derivative. So that means first function 1 as it is, d2 means derivative of the second, plus 2d1. And you can sing this song in any way you want, like 1d2 plus 2d1. Product rule is so much fun. 1d2 plus 2d1. Product rule is so much fun. I'm not a great singer, but you're welcome to use your own song. Let's do one example using this. So let's say we have this function y is equal to x squared 4x plus 3. So we have the product of two functions here. So you can think of this as u and think of this as v. And when we take the derivative, so we can expand this as 1 d2, so take the derivative of the second, plus 2d1, so second function as it is, d1, so derivative of first function. So here we got x squared, so derivative of 4x is just 4, and derivative of 3, which is a constant, is just 0. So 4 plus 0 is just 4, plus 4x plus 3 as it is, and then derivative of x squared is 2x. So we can simplify this further. So we get 4x squared plus, so 8x squared, and then 3 times 2 is 6x. So we get 12x squared plus 6x as our derivative of this given function. So this is our product rule. In the same example, so other method would be, so second method. So you can use the derivative of polynomial rules that you already know. So in this case, because this is a much simpler function, so you could start with x squared times 4x plus 3. And the first step that you can do is you can expand it. So y is equal to, so this becomes 4x cubed plus 3x squared. And then you take the derivative on both sides. So here we take 4 as it is, take the derivative of x cubed. 3 is a scalar multiple again, so take the derivative of x squared. And we notice that we get 4 and derivative of x cubed is 3x squared plus 3 and derivative of x squared is 2x. So overall we get 12x squared plus 6x, which is same as before. So you can use any of these methods to solve the problems, but sometimes it's not so simple. We cannot expand the expression, otherwise it will become too complicated. So then the best way to solve the problem is to use the product rule. So let's take a look at the next example, which is a little bit more complex. In this one, first we're going to rewrite the function. So we are given that y is equal to x raised to power 5 over 3, 3x7 minus 6x raised to power 5. So again, we see that we have the product of two functions, so u and v. And for taking the derivative, so let's take the derivative on both sides. So derivative of product is, so first function as it is, derivative of second plus second function as it is, and derivative of first. All right, so then we get, so x raised to power 5 over 3 as it is. Then 3 is a scalar, so x raised to power 7. So you bring the power down and reduce the power by 1. So you get 7 times 3. So 3 times. So derivative of x7 is 7, x6 minus, so 6 is a scalar, and then you bring the power down, so 5x 4. So these are multiplication. Similarly, in the second one, 3x7 minus 6x5 as it is, and then for the derivative, you bring the power down, reduce the power by 1. So 5 over 3 minus 1 would be 2 over 3. So we get x raised to power 5 over 3. So we get 21x6 minus 30x4 plus 3x7 minus 6x raised to power 5 and 5 over 3 x raised to power 2 over 3. So if you want to simplify it further, so you can take the common factors out. So in this case, x raised to power 2 over 3 is a common factor. So here we're going to be left with x times 21x6 minus 30x raised to power 4. And here we are left with 5 over 3, 3x7 minus 6x 5. Expanding it further, we get, so 21 x raised to power 7, then negative 30 x raised to power 5, and even in the second one, so 3 and 3 cancels, you get 5x7, and then negative 2 here, so negative 10 x raised to power 5. So now we combine any like terms. So in this case, so 21 plus 5, so 26 x raised to power 7. We combine any like terms, so 21 plus 5, 26. So we got x raised to power 2 over 3, 26 x raised to power 7, and then minus 30 minus 10. So negative 40 x raised to power 5. So this is our simplified answer. So for the product rule, so you go first function as it is, derivative of second plus second function as it is, derivative of first. So that's what the product rule of derivative is all about. And you can always sing your song and have all the fun. So I hope you enjoyed this video. So please do watch the next video to understand the quotient rule for derivatives. Thanks for watching.